Let's talk about how to use the 5 exponent properties to solve these 3 problems. Okay, we're supposed to simplify this problem. Notice we've got all sorts of exponents there. This one, this one, this one. Well, what are we going to do? Notice if you have 2 things to the 3rd power, we can use rule 4 to break that apart to 2 to the 3rd, x to the 3rd, y. Here, again, in the denominator, we can use rule 4 to get x to the 7, y to the 7, x to the negative 3. Now, let's go ahead and use rule 1 to put these powers together here. By commutativity, I can move this past, then 3 plus 7 plus negative 3 is going to be x to the 4, y to the 7. 2 to the 3rd, we can actually calculate that out, it's 8. Then we have x to the 3rd, y. Now what happens using rule 2 if I have x to the 3rd over x to the 4th? Now you actually have 2 options here. One option is we can write that, as this rule says, as x to the negative 1. And then y over y to the 7. You could think about this as y to the 1. And you could write this as y to the negative 6. That would be a perfectly appropriate answer. Another appropriate answer would be to say, you know, this rule tells us, actually, that a to the negative 5, for instance, is actually just a to the 0 minus 5, which is actually a to the 0 over a to the 5. In other words, a to the negative 5 is 1 over a to the 5th power. So if you see a negative sign there, this rule tells you you can write that as 1 over a to the 5th. So when I see a negative 1 there, I could write this as 8 over x to the 1st power over also y to the 6th. So this would be an appropriate answer as well. Okay? How about this problem? Well, notice, first off, what I'm going to do is I'm going to treat this as a single symbol in the numerator. So I've got these 2 symbols. Using rule 4, I can distribute that 4 to both of these. So I get x plus y squared to the 4th, then x to the 3rd to the 4th. Now I can use rule 3 on these. I actually multiply those exponents. Now, and I've forgotten to write my denominator. I'll do the same thing in the denominator. xy to the 4th squared, and then y squared. Now, often I wouldn't actually write this step out. I'm writing it out for clarity. Often I would distribute this out and I'd multiply in one step because this gets distributed to the 2. Then they multiply using rule 3. So I get x plus y to the 8, x to the 12, xy to the 8, and y squared. Here you have to be careful. There is no rule for distributing a power across a plus or a minus. That term you are stuck with and you're going to end the problem with that. Now here, you can actually distribute that across here. That is simply rule 4. So we can use rule 4 there. So I get x plus y to the 8, x to the 12. Here I get x to the 8, y to the 8, y to the 2. Okay, now let's think about what's happening here. I can use rule 1 to combine those 2 pieces. So I get x plus y to the 8, x to the 12, over x to the 8. Combining these 2, I get y to the 10. What happens if I have x to the 12 divided by x to the 8? Well, by rule 2, that leaves me with x to the 4th in the numerator. That's probably about as simple as you're going to get that problem. Okay, last but not least, I guess we haven't used rule 5, so let's use rule 5 here. Think about what happens here. I'm going to have t to the third over s to the third. Here I'm going to have 3s squared over t squared. Now, remember, by commutativity, we can flip these around and we can actually think about all of these terms separately. Here, I'm still going to have to use rule 4. So t to the third over t squared, then 3 squared s squared over t over s to the third. Moved those terms. Okay, this comes out to t. This comes out to 9. This comes out to an s in the denominator, not an 8, but an s. So typically we would write this as 9t over s. I hope that helps.